Hello, everyone. Welcome back to our actual lesson for today. So, our I can statement says I can find all the factors of a number. So, let's learn how to do that. Again, I've taught all day, so my throat is a little scratchy, whatever. So, I sound a little hoarse because I'm out of practice, and so my throat is kind of raw. So, I apologize for the rough sound. Hopefully, it'll be better in the next few days. Um, the next one, we've got some notes at the top. Remember, factors are numbers that go into the larger number. It's the small number that goes into the large number. 2 is a factor of 18 because 18 divided by 2 is equal to the whole number 9. Notice the converse of that, the flip of that does not work. It says 9 is a factor of 3. Well, this is not true because 9 does not go into 3. Now you try. What are the factors of 6? So we start with our broadest pair, 1 and 6. We're in our factory or making 6. So we got 1 and 6. We also have 2 and 3. So notice I'm putting those in order 1, 2, 3, and 6. I started with my broadest pair, 1 and 6. Then I work my way in 2 and 3. Because they are side by side, we know that we found them all. 2 and 3 are side by side, so we know we found them all. And we went in order 1, 2, 3, so we know we found them all. Every number greater than 1 has at least two factors because every number can be divided by 1 and itself. So we're going to add the number 1 in there and itself. All right. Now, I want to think about the numbers that make 10. What goes into 10? We're making 10. So if we want to make 10 in our horseshoe factory or in our factor, it's a factory, so we're making 10. What pair together to make 10? 1 and 10. Now, we go to 2. Does 2 go into 10? Sure. 2 times what makes 10? 2 and 5. Now, 3 is not a factor of 10 because if I divided that, I would get a decimal. 10 divided by 3, that doesn't give me a whole number. And 10 divided by 4 doesn't give me a whole number. So I know the next number is 5, so I know I found them all. Notice I'm going in order. 1, 2, and then my numbers get closer and closer together. Okay? What are the factors of 30? 30 has a lot of factors. It's called an abundant number. So I want you to watch what I'm doing here. I'm going to insert a text big over here on the side so you can see what I'm doing. I'm making a list, and I'm thinking about that broadest pair. I want to think about as big as I can get it. How far apart can I get them? Well, the smallest I can go is 1. We know that 1 times 30 gives me 30. Now we're going to try 2. Notice I'm going in order. 1, 2. 2 times a number gives me 30. Count by 2s. That gives me 2 times 15. Now I'm going to try 3. Notice I'm going in order. 1, 2, 3. 3 times 10 gives me 30. So look what happens. My gap starts really big. 1 is my smallest, 30 is my biggest. 2 is next, and 15. Now we've eliminated all the numbers right here, 16 through 30. They're eliminated. They're not factors of 30. We've already pooped them out. Now what we're trying to do is get our numbers closer and closer together until we run together, so we know we found them all. So the next number we check is 4. So 4 times something, does that give me 30? 4 times 7 gives me 28. 4 times 8 gives me 32. So notice we skipped it. So 4 is not a factor of 30. Then we go 5. Well, 5 and 6. Look what happened to my range. It runs into each other. I call these guardrails. So think about your guardrails. Your guardrails start out really, really wide, 1 and 30. Then it scooches in, 2 and 15. Then it scooches in again, 3 and 10. Notice I have a not very big gap. Then 5 and 6 run into themselves, so I know I found them all. The last one says, Edgar needs to arrange some chairs for a drama club at their school. There are 32 students coming. How many ways can you arrange? So that's the same thing. How many ways can you arrange the chairs so that as there's the same number? We're dividing those chairs out into different arrangements. So you could have a 1 by 32. You could have a 2 by 16. So look what happened. My guardrails went from really big from 1 to 32. 1's as low as I can go. 32's as high as I can go. And then they start to come together and creep in. So 2 and 16. Now we've eliminated a bunch of numbers by going in order with the small numbers. 3 is not a factor. 3 times 10 is 30. 3 times 11 is 33. See how we skipped 32? So we know 3 is not a factor of 32. You could also divide 32 by 3 and get a decimal and see that that doesn't work. Then we got 4 and 8. 4 times 8 is 32. 5 is not a factor of 32. 6 is not a factor of 32. 7 is not a factor of 32. Now we've got 8. So notice we didn't completely run into each other, completely like we did with 5 and 6. But notice that we are really close together and the numbers between 4 and 8 didn't work. 5 didn't work. 6 didn't work. 7 didn't work. 8's already there, so we know we found them all. So those are the possible arrangements that you have. You could also flip those around and do a 32 by 1, a 16 by 2, and an 8 by 4. So those are the possible arrangements that you have. You have 1, 2, 3, 4, 5, 6 different arrangements. And notice you also have 6 different factors. All right, that's a little tidbit, a little piece of advice there. All right, so you have one that started for you. These are the factors of 12. So you're just going to put these in your horseshoe, 1 and 12, and then you're going to write 2 by 6, 2 times 6, 3 times 4. Notice they run into each other. I went 1, 2, 3, 4's on the other side, so I know I found them all. You're going to do the same thing for these. I want to talk about 37 for a minute. 37 is a prime number. That means it only has 1 and 37. Those are the only 2 factors of 37. Let's take a look at 56. It seems like a large number. Here's one more together. 1 and 56, 2 and 28. That's a big number. 3 won't go. Now, here's how I know that. I could either divide it out, or 5 plus 6 is 11. 3 doesn't go into 11, so 3 won't go into 56. This is a divisibility rule for finding out if a number is divisible by 3. If you don't want to use that, you don't have to. If that's not familiar for you, that's fine. Just take a calculator and divide it out. There is one down here. Go down here in your little circle and you hit calculator. If it's not down there automatically, you can type the word calculator in and it will pull one up, although it didn't do that for me. All right. So 4 is a factor. 4 and 14. And then we got 5 is not a factor because it doesn't end with a 5 or 0. 6 won't go because 2 and 3 didn't go. So those are some of the divisibility rules that I'm kind of going over pretty quickly. If that doesn't make sense to you, just divide each one out until you run into it yourselves. So 6 is our next number. It didn't go. 7 is a factor of 56. So 7 times 8. And notice we're smack dab beside each other. And because we went in order, 1, 2, we tried 3, but it didn't work. 4 worked. 5 didn't work. 6 didn't work. And then 7 works. So notice we're going in order. And then 8's on the right-hand side. So because it's already on the other side, we know we found them all. This might be challenging for you. Try some of these, see how you do. And then finally, your exit slip today says list all the factors of 16. So I want you to list them all, go in order. And then when you run into yourself, that's how you know you found them all. So when the numbers are side by side, or when you have this guardrail, what's your broadest pair? Does 2 go? Does 3 go? Does 4 go? Keep going in order until you know you found them all. Think of it as a horseshoe that starts out broad and then it works its way in. I hope that makes sense. This assignment is just meant for you to try. No pressure. Do it. Just try it. If you have any questions on your Google Classroom, come down here and click a comment. If you comment on this, hey, Miss Brannick, I need some help, I'll be glad to help you in a Google Meet, and I'll be glad to see what I can do to help you understand. Have a blessed day. I'll see you tomorrow as we continue to learn about factors.